So in this video, I'm going to start talking about surface area and volume. It's task 26 in your packet. So first off, what is surface area? So surface area is literally the sum of the areas of each of the faces that make up a figure. So think about a cardboard box, and if you pulled it apart and you laid it flat, that is called a net, which we'll talk about in a minute. But if you found the area of each of those sides of the box and added it all up, that would give you the surface area. And the surface area is really the amount of cardboard for the box, right, or whatever material is making up the box. So if you think about surface area, examples are like if you're painting a room, if you're painting all the walls, it's called lateral area because you're not painting usually the floor. But you could also paint the ceiling. But that would be an example of surface area. Carpeting a floor is an example of area. And then when you talk about volume is the second type of measurement we're going to be interested in. And volume is the amount of space a substance or object occupies. So it's more about like how much you need to fill up something or how much material goes inside of it. So think about like the amount of dirt in a pot, the amount of water in a container, the amount of like packing peanuts you need in a box. Those are all more examples of volume. So just as a reminder of our shapes and the parts, you need to know this to help you find surface area and volume. When we have a prism, we have two polygons. Most of the time they're regular polygons that are parallel. And then we have rectangles or squares that are between those two polygons. And what we do is the two polygons we call the base. So in this case, it's the two hexagons are the bases. Again, it can be turned on its side, but we still consider those the bases. The altitude, also known as the height, is always the distance between the two bases. So we usually draw it in the middle, but it's also like one of these sides would also be the height. The parts that are not the base are called lateral faces. So all the rectangles are lateral faces, and where the two rectangles meet are called a lateral edge. And then we have cylinders. And cylinders are very similar to prisms, except the bases are circles. So again, you can draw it sideways like this or up and down. But again, my bases are the circle. So this is one base and this is my second base. The distance between those two bases is the height. So either here or this distance. And then we have the radius of the circle. And so again, we have our bases, and then this middle part here is again called the lateral face. And if they ask you for a lateral area, we're just finding the area of that part and not the bases. And then we have pyramids and cones. So for a pyramid, we have triangles that all meet at a point called the vertex, and we have the base, which is a polygon. Most of the ones we're going to do are rectangles or possibly a triangle. But this one is a hexagon. So we have, again, the height or the altitude. And the height or the altitude goes always from the vertex to the middle of the base, and it makes a right angle with the base. And then these triangular faces are all called the lateral faces. Okay, again, the lateral faces are all the ones except the base. And where those two triangles meet is called a lateral edge. And we are going to use something called slant height. So the slant height goes down the middle of one of those triangles and makes a right angle with one of the with the middle of the side of one of the bases. That's called the slant height. And you can draw it on any side of your pyramid. And notice the slant height and the height actually make a right triangle. So sometimes we'll be missing one of those, and we'll use Pythagorean theorem to find the height or the slant height. So if I just put an A here to represent this side length, we would do this as our Pythagorean theorem, with our slant height always being our hypotenuse. And then for a cone, it's the same thing. We have our vertex, okay? We have our base. The height or the altitude goes from the vertex to the middle of the base. And the slant height would be here or on this side. And the slant height goes along the cone to a point on the circle. Okay? And again, this is my radius of my circle. The height and the radius and the slant height make a right triangle. So we can use Pythagorean theorem with our slant height always being the hypotenuse to find one of them if we're missing one of them. Okay, so those are all the parts of my figures. And that's important to know because we're going to use this vocabulary when we're defining the formulas. So if you roll out these figures, they would look like this. So this is a rectangular prism here. And if I kind of roll this out, this is called a net when you like flatten the figure and you just look at all the faces. Okay. So my green areas are my bases for this. And the purple and pink rectangles and squares are the lateral faces. And then for my pyramid, like I have my square in this case is the base, and then the triangles are the lateral faces. And then my cylinder, I have my two circles, which are my bases, and then this blue rectangle is my lateral face. Same thing, this is my base, and this is my lateral face. So we're going to talk first about lateral surface area, or most of the time they just say lateral area. And lateral area is the surface area of the sides of the prism or the pyramid. It does not include the bases. So it's the area of all the regions except the bases. And these are the formulas. So the cylinder is 2 pi r h. And why that is because if you look at the cylinder, it is a rectangle. Remember, a rectangle is length times width. Well, the length or the width is height, the h, and then the length is 2 pi r. And that's because this distance is the same as around the circle. So it's actually the circumference of the circle. And so the lateral area is we're just doing like length times width, which is the height times 2 pi r. And we just usually write it the other order, 2 pi r h. So the same thing for the rectangular prism, if we're finding the lateral area, we would take the area of each of these rectangles and multiply them together. What we found that a shortcut is that this is our height, and then this length here that I'm outlining is the same thing as the distance around this rectangle, which is the perimeter. And so for a pyramid or prism, the lateral area is the perimeter times the height. So P is the perimeter of just one base, and height is the height of the prism, which again is the distance between the two bases. Okay, the pyramid is kind of the same idea. The lateral area is 1/2 the perimeter times L, the slant height. So it's the perimeter of this base, and then we multiply it by the slant height because the slant height is going to be the height of each of these triangles, right? And the perimeter of the base gives me the base of each of these triangles together. And then the cone is the last one. It's not really a shape that you know, the area of a circle, or the sector of a circle, but what it's going to come down to is the lateral area of a cone is pi RL, where R is the radius of the circle and L is the slant height. Okay, so those are all my lateral area formulas. Most of these will show up on the homework, but they are good to know. All right, and then in the next few videos, I'll talk about surface area and volume.